Welcome to The Explainer. Today, we are diving into a really groundbreaking paper that might just have the secret recipe for the next generation of AI. We're talking about a unified theory, one that connects pretty much all modern AI models, from transformers to Mamba, under a single elegant framework. So let's jump right in and see how it's all connected. The paper really kicks off with this huge question, one that researchers have been wrestling with for years. What if, instead of building every new AI from the ground up, totally from scratch, there was a single, fundamental blueprint, a kind of instruction manual that could not only explain every model we already have, but also let us invent entirely new ones? Now, to really get why this blueprint is such a big deal, we first need to talk about a massive problem that even the most powerful AIs are facing today. It all boils down to a problem with memory and, well, with scaling. Okay, so right at the top of the AI food chain, you've got transformers. These are the engines inside models like GPT-4, powering so many of the tools we use every single day. They are incredibly powerful, no doubt about it. But they have a critical and very, very expensive weakness. So here's the core issue, right? As you give a transformer more and more information, like a super long article or a whole movie, the amount of computer power it needs doesn't just go up, it absolutely explodes. It scales quadratically, which basically means a little more input requires a ton more power. This makes trying to analyze really long things incredibly inefficient and just ridiculously expensive. So, faced with this kind of computational wall, researchers did what they often do. They looked for inspiration in, you guessed it, the most efficient information processor we know of, the human brain. Think about how our own memory works. A core idea behind it is something called associative memory. It sounds fancy, but it's actually super simple. It's just the brain's ability to link related things. You hear a key, like someone's name, and you instantly pull up the value, which is their face. This key-to-value mapping is absolutely fundamental. And our brains are always deciding what's important. I mean, imagine you're in a super crowded, noisy room. Your brain just filters out all the background noise, right? But the second someone says your name, boom, you snap to attention. That's your attentional bias. For an AI, this is like its internal goal. It tells the model what it should actually pay attention to and learn from. So by taking these two big ideas from how the brain works, associative memory and attentional bias, and translating them into a computational framework, the researchers came up with this powerful new blueprint, and they gave it a really cool name, Miras, which actually means legacy in a few languages. And this one diagram right here pretty much shows you the whole concept at a glance. What Miras is proposing is that every single sequence model is basically just an associative memory system. And to build one, you just have to make 4 key choices, almost like you're picking from 4 columns on a restaurant menu. This framework basically turns AI design into this awesome mix and match game. You choose how to store memories, you pick what the model's internal goals should be, you decide how it should forget old information, and you select the algorithm it uses to learn. The wild part is by just picking one option from each of these categories, you can't just describe old models like transformers. You can literally invent brand new ones. So how does this blueprint actually help you create new models? Well, this is where it gets really interesting. The real power here isn't just describing what we already have. It's showing us what's possible when we start using new ingredients that go way beyond the standard choices. Okay, for example, most models use a pretty simple learning goal that gets totally thrown off by weird or noisy data. But with the Miras framework, you can just swap that out for something way more robust, like Huber loss. It's this clever hybrid that basically gives the model a coping mechanism. It treats normal data one way, but if it sees a crazy outlier, it just switches strategies so it doesn't mess up its learning. And the same idea goes for forgetting things. Standard models just use a simple decay function. Memories just kind of fade over time. But with this, you can install a much smarter retention gate, something like KL divergence. It lets the model make way more sophisticated decisions about what old information it can safely forget to make room for new, more important stuff. And just to be super clear, this is not just some theory on a whiteboard. Nope. The researchers actually used this exact blueprint, this recipe book, to design and build 3 totally new AI architectures from the ground up, each with its own unique strengths, Moneta, Yaad, and Memora. But of course, the real question is, does this whole new way of building models actually work any better? I mean, are these new creations any good? Well, let's take a look at the results. All right, this first chart here plots performance. And remember, lower is better against how much it costs to run. And right away, you can see it. The lines for the Miras models are way down below the others.
What this means is that for the exact same amount of computing power, they get better results than both transformers and other top-of-the-line models. They're just flat out more efficient.
And this is where you see the real superpower. This chart shows what happens when you feed the models longer and longer streams of information. You can see how the older models start to struggle. Their performance gets worse and worse. But the Miras models, they just keep on trucking. They maintain their edge. They were built from the ground up to handle long-form context, which was the exact problem we started with. So there's this test called needle in a haystack, and it is a brutal test of long-term memory. The AI has to find one tiny fact that's buried in a gigantic document. And just look at these results. Previous models were finding that needle, 50 to 75% of the time. The new Miras models, they're finding it over 90% of the time. That is a massive, massive leap in recallability. So what's the big picture here? What's the major takeaway from all of this? I mean, why does a new framework matter so much? It really comes down to this quote from the paper. See, Miras isn't just about the 3 cool new models they built. It's a fundamental shift in how we think. It's a clear, repeatable process for designing AI. It literally hands researchers a toolkit to build specialized, powerful, and super efficient models that are tailored for any task you can imagine. It's creating a whole new legacy for AI design. This framework really does open the door to a whole new era of AI architecture. It helps us move away from just tweaking old designs and pushes us towards creating entirely new kinds of intelligence, purpose-built for the challenges of tomorrow. So the question is no longer how we build smarter AI, but with this blueprint in our hands, what on earth are we going to build next?